Alright, in this video I'm going to show you how to graph piecewise functions. And number 5, I'm actually going to show you 2 ways to do it. I'm going to show you how to do it without a calculator and show you how to do it with a calculator. So when I look at this top piece, I'm thinking y equals negative 2x plus 4. Okay, so I'm just going to graph that line for starters. So the y-intercept is 4, so that's right here. And then the slope of negative 2, that means down to right 1. So that would be like this. Down to right 1. And I could continue that pattern in the other direction. So these dots sort of show you what this line looks like. However, we don't get to graph this entire line. We're just going to graph the part of the line where the x values are less than negative 1. Even though it says less than negative 1, actually start off with the point that is at negative 1, exactly on negative 1. So hopefully you can see that I'm talking about this point right here. Okay? For example, this point is at 0, this is at positive 1, positive 2. This point is at an x value of negative 1. Now this is going to be the end point of this piece. We're going to make it an open circle because the point at negative 1 itself is not to be included. We just want x values that are less than negative 1. So to show that this is not included, we're going to make it an open circle like this. Okay, so open circle at negative 1. Now we want x values that are less than this, less than negative 1. So that's why we're going to go to the left. All right, negative 2, negative 3, negative 4. These are the values that are less than negative 1. So that's why I'm going to draw the graph in this direction through these points that I have plotted. All right, and then erase any extra dots that you made by this method. So that's what the first piece looks like. Now, looking at the second piece, think y equals x minus 2. Again, the y-intercept would be negative 2, so that would be right there. And then the slope is 1, so, 1 over 1. So that would be up 1, right 1, like this. And it could continue to the left as well. But again, we are not going to draw the entire line. We're just going to draw the part of the line where the x values are greater than or equal to negative 1. So because of the negative 1, that's going to be the end point of this piece. So pick which one of these dots is at negative 1, x value of negative 1. So this dot right here has an x value of negative 1. It's 1 to the left. This one will be a closed circle because of the or equal to shows that this point is to be included. Now, the x values that are greater than negative 1 would be the ones to the right. So that's why we're going to draw this part of the line, because this is going to the right. And erase any extra dots that you have on the screen. So that is what this graph should look like, and that's how you would graph it without touching a calculator. Might as well go ahead and do the domain and range real quick. So the domain, this graph goes left forever and right forever. Okay, and with regard to the x values, this is unbroken because right where the blue function leaves off, immediately the red function picks up. So there are no gaps in the x values. So it simply goes from negative infinity to positive infinity. Now the range, bottom to top, the lowest value of the graph is here at negative 3, a y value of negative 3. And that's a closed circle included, so I'll do a bracket. And then it goes up forever. Both of these go up forever, so that's going to be infinity. Now I'm going to go back and redo this problem real quick. all right? Because some of you will prefer to use the calculator method, which is also quite easy. So I'm going to use my TI-30XS multi-view, because that's what I do. Okay, it's all about the table feature when you're going to do this. So look at that first equation, and again, we're thinking, I'm going to do this in blue. We're thinking y equals negative 2x plus 4. So that's why I'm going to type in negative 2x plus 4. Okay, now in terms of where to start, use this domain restriction. That negative 1 is going to be your endpoint, so that's where you're going to start, negative 1. So negative 1. Enter, 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 enter. So this is going to be my endpoint right away, negative 1 comma 6. And again, it's going to be an open circle. So negative 1 comma 6, you put your open circle. So by this method, you don't need all those extra dots and all that stuff. You just go immediately to the right spot. Now, we want x values that are less than negative 1. So I'm looking at my calculator. X values that are less than negative 1 would be like negative 2, negative 3, like that. So that means we're scrolling upward. Okay, so for example, we've got negative 2 comma 8. All right, would be right there. And negative 3 comma 10 would be right there. All right, so right away, you really can't go wrong if you're doing the calculator method. So it takes a little bit more time in the sense that you have to involve the calculator and type stuff in. But once you've done that, it's kind of foolproof. You're almost guaranteed to have the right answer. So let's do that same thing for the bottom piece, y equals x minus 2. So table feature, and so there we have the x minus 2. Again, we want to start off at this domain restriction number of negative 1. So there's your negative 1. Enter, 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 enter. So this endpoint is going to be at negative 1, negative 3. Okay, so negative 1 comma negative 3 will go right there. This one will be a closed circle because of the or equal to. So here we go, negative 1 comma negative 3. Boom. Now we want the x values that are greater than or equal to negative 1. So greater than negative 1, we're talking about 0, 1, 2. So we might as well graph this, 0 comma negative 2. All right, would be right here. 1 comma negative 1 would be right here. And you see the pattern that's happening. I'll just do one more. 2 comma 0 is right here. But you see that it's going up 1 over 1, which we also know from the slope. So it's going to just continue that pattern in that direction. All right, so you really can't go wrong if you're using the calculator. So if you need it to help you make sure you're accurate, then use it. All right, problems like number 6 are so simple that we won't speak in terms of using a calculator for these because that would be silly. So what we have is this first piece is y equals 0. All right, y equals 0 is just a horizontal line. So if I were looking at the entire line y equals 0, it would look like this. It would just be a horizontal line at 0 like this. So we don't want the whole line. We just want the part of that line where the x values are less than negative 6. So go to negative 6, and we're going to put an open circle, all right, because we want less than negative 6, not negative 6 itself. So open circle shows it's not included. And then because it's less than, we're going to show the values going to the left. Okay, that was a little crooked, so that's bugging me. Let me try that again. All right, so that's what that first piece is going to look like. And so for the second piece, think y equals negative 2. And again, y equals negative 2 is a horizontal line at negative 2, like this. Okay, when you see this kind of domain restriction that has a beginning and an end, you should think between. I didn't leave myself space for that. I said you should think between. All right, we want the values between negative 6 and negative 1. So along this line, here's negative 6, and here is negative 1. Okay, now at negative 6, it's or equal to negative 6, so we'll make this a closed circle to show that negative 6 is included. We'll leave this one an open circle. So between negative 6 and negative 1 is going to be like this. So you're going to have a segment when the domain restrictions are like that. So that's what the middle piece should look like. And the third piece, think y equals negative 4. So that would be a horizontal line at negative 4 like this. So we want the x values that are greater than or equal to negative 1. So here's the value that's at negative 1. We'll go ahead and make it a closed circle because or equal to negative 1 includes the point at negative 1. And then since we want the values that are greater than negative 1 as well, we will draw that going to the right. Okay, so that's how you graph this type of a piecewise function. Now the domain is going to work like normal. This graph goes left forever and right forever, and there are no x values that are not included. So the domain is just going to be negative infinity to positive infinity. We have to be more careful with the range though. Because these are horizontal lines, we're not hitting all of the y values between negative 4 and 0. So I can't do interval notation and just say, okay, the lowest values are at negative 4, the highest values are at 0, so negative 4 to 0. Because that would include all of these values, for example, between negative 4 and negative 2. But this is empty space here. There are no y values on the graph between these two pieces, or between the blue piece and the red piece. So really there are only 3 y values included in this graph. And those y values are the green part, all the y values are negative 4. For the red part, all the y values are negative 2. And for the blue part, all of these y values are at 0. So negative 4, negative 2, and 0 are the only y values shown here. So the way you do it when you have just a short set of values that you can actually list is you just list them. So we'll use a brace like this, and we'll simply write negative 4, negative 2, and 0. Okay, that's how you do it when you have what you call a finite list, meaning a limited list as opposed to an infinite range. Okay, so that's it. That is how you graph piecewise functions.